Okay, so we're resuming the June 2007 foundation tier paper. It's the completion paper MF or N5 paper 1, and we're going to go straight into question 11. This question here is all about transformations. The three questions they're asking is 11A is, what's the single transformation that takes triangle A to triangle B? So hopefully you can see that the two triangles still look the same. They're in the same shape. They haven't rotated. They haven't flipped over. So that's an indication that it's a translation. And the translation in this case is 8 squares over, 1, 2, 3, 4, 5, 6, 7, 8, and 3 squares down. And the way we write that, we have to remember now, we have to write this in this vector notation. So you need to write translation, and then we've got 8 is the number on the top, meaning 8 squares to the right, and minus 3 means 3 squares down. Okay, the second one then is, what's the transformation that takes triangle B to triangle C? Hopefully you can see here, this time going from B to C, the triangle has been flipped over, and that's an indication that it's a reflection. And so you need to state the word reflection, but you also need to give the mirror line. And hopefully you can see the mirror line is the line halfway between the two triangles. So in this case, it's the x-axis. So the answer there is a reflection in the x-axis. Okay, the third one then is, what's the transformation that moves triangle D to triangle B? Again, what you need to spot here is that this triangle has been rotated round to get to this triangle. So we're talking about a rotation here, and you need to get a piece of tracing paper. So you're going to put your tracing paper over the grid. You're going to trace triangle D, and then you're going to look for where do you hold the tracing paper, so that when you rotate the tracing paper, this triangle rotates round and lands on top of this triangle. The first place to try is the origin, this point 0, 0, and it's usually a good idea to do a little arrow pointing upwards, because we're going to be able to follow that arrow and see how much of a rotation occurs. So as you can see, when we move the tracing paper round, the arrows move through 90 degrees in a anti-clockwise direction, and it's landed on top of triangle B. So the answer there now then is, it's a rotation. We've got to indicate what the movement is. It's 90 degrees anti-clockwise. And the third thing we have to give is the center of rotation, which is either the origin or this point 0, 0. We can call that either the origin or 0, 0. Okay, so have a look at question 12, and we'll go through it in a few seconds. Okay, so 12A, they've given us a little calculation. 38 times 256 equals 9728. They want us to find the value of 9728 over 2.56. So we want to rearrange this little equation here so it resembles this. So we're going to write 9728 is equal to 38 times 256. We've just switched that around. Now we're going to bring over the 256. 9728 divided by 256 equals 38. So now the difference between this one, which is dividing by 256, and this one here, which is dividing by 2.56. So we're now dividing by a much smaller number. So this means the answer is going to be a lot bigger. So in fact, we've moved this decimal place 2 places to the left to make the number smaller. We have to compensate for that by moving the decimal point here 2 places to the right, so our answer is 3,800. So the 38 becomes 3,800. For part B, they have highlighted the main word here, which is estimate. And the thing to remember there is we're going to round all the numbers to one significant figure, and then we'll be able to do the calculation with the rounded numbers. So 498, that's a number in the hundreds, so we're going to round to the nearest hundred, which is 500. 6.21, that's a number in the units, so we're going to round to the nearest whole number, which is 6. And 0.215 to one significant figure, in fact it's to 0.2 to the nearest tenth. So we multiply the top out, 500 times 6 is 3,000, so now we've got 3,000 divided by 0.2. There's a little bit of a trick here. When you're dividing by a decimal, what you have to do is get rid of the decimal on the bottom of the fraction here. And how do we do that? We're going to multiply this number 0.2 by 10, and that gets us the number 2. So we have to do exactly the same on the top. We've got to multiply the top by 10, and 3,000 multiplied by 10 gives us 30,000. So now we end up with 30,000 divided by 2, and that is 30 divided by 2 is 15, and then we've got our 1,000. So the answer is 15,000. Okay, so there's question 13. If you want to stop the video and have a go at that, we'll go through it in a second. Okay, so this probability question, you're given a table with the probabilities given, and they ask you to find a missing probability. Thing to remember here is that these probabilities will add up to 1. So when you add up 0.2, 0.25 and 0.15, it gets 0.60. So the remaining missing probability is going to be 1. Take away 0.6, which is 0.4. So the missing probability for picking a yellow is 0.4. Second part, part B, which color are you least likely to get? So again, you need to know that least likely means the smallest probability in the table. And when you look along the table there, the smallest probability is 0.15, and that color would be pink. And then part C then, how many green bubble gum will be in a batch of 60? For this one, you need to think that from the table, the probability of getting green, it tells you here, is 0.25. So what that means is, if you pick a color once, you expect to get green 0.25 times. But they want to know if you pick the color 60 times, therefore you'd expect to get 0.25 multiplied by 60. So that's like a quarter. 0.25 is a quarter of 60. Hopefully you'll remember that that's 60 divided by 4, which is 15. So the answer there is 15. Okay, if you have a look at 14, stop the video and we'll have a go at it. We'll go through it. Okay, for question 14 here, the word I've circled here is simplify. And really, for doing these power questions or indices questions, there's a rule here when you're multiplying two indices like this. So the rule is that you add the two power numbers together. So the answer there, c to the power of 6 times c to the power of 4 is going to be c to the power of 6 add 4, so which is c to the power of 10. Now, obviously, if you can remember that rule, then you'll be able to work that out. But another way of thinking about it, just go back to basics and remember that 6 to the power of 6, the power number tells you how many c's are multiplied together. So that's 6 c's multiplied together. C to the power of 4, the 4 tells you how many c's are multiplied together there. So with another 4 c's multiplied together there. So hopefully you can see that's 10 c's multiplied together, and that's c to the power of 10, which is the same as we have here. And the second part then, m to the power of 8 divided by m to the power of 2. Again, there's a rule, one of the power rules or indices rule, is that when you're dividing, in this case, you subtract the two power numbers. So m to the power of 8 divided by m to the power of 2 is m to the power of 8 minus 2. So that's m to the power of 6. Again, going back to basics, what that really means is m to the power of 8. The 8 is telling you you've got 8 m's multiplied together. And then we've got a fraction line, a dividing line, divided by m squared, or m to the power of 2, m times m. So you can cancel an m on the top and an m on the bottom, another m on the top and another m on the bottom. And then you end up with 6 m's multiplied together on the top, which is m to the power of 6. Okay, so there's question 15. If you want to stop the video and have a look at that, and we'll go through the answer in a second. Okay, so for question 15, what have we got? We've got a coin which is tossed and a fair dice is rolled, and they're asking us about a probability of getting a tail and a 4. Right, there's a couple of methods of doing this. One method you might be familiar with is to draw a two-way table, or you might know it as a sample space diagram. So we write down, do a little table like this. So we put all the outcomes that you get when you roll a fair dice, 1 up to 6. And when you toss a coin, you can get a head or a tail. So you complete all the different things you can get. You can get a head and a 1, a head 2, a head 3, and so on. Or in this row, the coin would be tail and a 1 on the dice, tail and a 2 on the dice, and so on. T3, T4, T5. So you can see there's 12 different outcomes or results that you can get when you toss a coin and roll a fair dice. So what they want to know is, what's the probability of getting a tail and a 4? So hopefully you can see there's only one result, which is a tail and a 4. But that's 1 out of a total of 12 different outcomes or results. So the probability of getting a tail and a 4 is 1/12, or 1 out of 12. The second method, which some of you may be more familiar with, is just to think of what's the probability of getting a tail when you toss a coin. Of course, that's a half. And again, when you roll a fair dice, what's the probability of getting a 4? So there's 1 4 out of a total of 6 faces on a dice, so that's a probability of 1/6. So to get a tail and a 4, then you need to remember the rule says that you're going to multiply the two probabilities together. So multiply a half multiplied by a 6, and that gives you the same answer as we got up there, which is 1/12.